Hey guys, you're going to write notes today. So have your paper out, pencil. Make sure you put today's date. Today's October 29th. We'll come across the title here in a second, so make sure you have that title so you know what you're looking at when you go back to your notes. You're going to need to have an example for each type of scenario that we're going to talk about here in a second. And you need to have an explanation for each graph. So every scenario is going to have a graph. And so every graph is going to have an explanation. We're going to learn about two types of motion graphs. You can determine the type of motion happening based off of the graph. And the two types is distance time graph and speed time graph. Sometimes you see distance time graph also as displacement time graph. And sometimes you'll see a speed time graph, also known as velocity time graph. But today we're going to focus on the distance time graph. Okay, this is what we're going to focus on. Today we're going to focus on distance time graph. Okay, we'll focus on the other one tomorrow. First thing you need to know about a distance time graph is the labeling on the y-axis, distance. This is really, really important because this is the only way that you can differentiate between the distance time graph and the speed time graph. You have to look at the labeling. So your Y label is distance and your X label is time. Okay? So as you go across, you're going through time, or time is passing. Time is passing. Okay? And as time is passing, there's going to show some kind of distance, either going away or going towards something. Okay? So distance increases as you go up the y-axis. So the further you go up, the farther you're getting away from something. The greater distance you're putting between, you and wherever you started. So let's say that you walk to school. This is home. And as long as it takes to walk to school, let's say this is 5 minutes, 10 minutes, 15 minutes. Let's say it takes you 15 minutes to walk to school. Within those 15 minutes, you're going to be traveling further and further away from home. So it depends on if you're going to go fast or if you walk really slow. It just kind of depends. But as time passes, that's going to be the farther you get away from something. So the vertical axis, which is our y, is going to be the distance. And then your horizontal axis is going to be time, just like we went over. Okay? Pause if you need to make sure that you have all of these notes, because already you need to make sure that you understand that the y-axis is going to have the distance and the horizontal is going to have time. So again, this is distance. The further you go away from the start, this is always going to be where you start on a distance graph, distance time graph. Okay, so it goes in increments. The higher up you go, the further away. Okay. Okay, and then down here, the further you go, that's how time passes. Okay, so let's look at a couple different examples here. We have a curved upward line. Okay. The gradient means how steep or how shallow the line is. So for A, okay, the gradient is increasing because it's going up. So that means the speed is increasing. Okay. So as time is passing, the lower you stay towards the x-axis, the lower you are, you're going pretty slow as time passes. But all of a sudden, about right here, it starts going upwards here. So as time passes, you're picking up the pace. You're going a little bit faster. So then we have this downward curve. That means you're slowing down. Okay, that means you're slowing down. So this is C. This curve is C. It's a decreasing gradient. Okay, it's a decreasing curve. It's going downwards. So that means your speed is decreasing. So you were la la la, just walking along, and then something, you started to slow down. Maybe you saw, cute little cat or puppy, and oh, that's so cute as you're walking. Okay. Then we have this straight line here. Straight means constant. You're at a constant speed. So as time passes, you're getting further and further away, but you're doing it at a constant rate. Okay? And then lastly, we have another straight, constant. Okay? But because this is flat, this is distance over here. So nothing is changing on the distance. So it's at this mark right here over a long period of time. That means you're staying at that same distance as you go. So because this is flat, they're staying in the same spot. There's no motion. So maybe they reached the destination where they were headed. Okay, so these are some examples of traveling towards home. We have home here, so or back to the original location. So the original location is going to be in the corner when we're talking about distance graphs. But this is from the get-go, from the start of time, they're somewhere else. Okay, they're far away from home. This is home, or the starting point. And as time goes on, they're getting closer and closer and closer to home, because this is home right here. Zero distance would be home, or the original place. Okay. As time goes on, you see they're getting closer and closer. Okay, same thing here. Same thing here. So for this one, they're heading home at a constant speed. For this one, they started off slow. Okay, there's hardly any bend to it. They started off slow, and then they sped up. I'm going to hurry up and get home. This one over here, they started off pretty quick. And then the closer they got to home, they started to slow down. These are examples of traveling away from home. So they started at home, and they're traveling as time goes on. They're traveling away. The distance is getting greater. Same thing here. Okay. So this one, they started off kind of slow, and then they got faster. This one, they started off pretty fast, and then they started to slow down. This one, they were going at a constant speed, and then they just stopped. They're staying at that same distant location over time. Okay. This one, they're not even at home, and they're not moving anywhere. They're just staying there. I think I skipped one. I went back. This one, we're starting at home. They left home, and they're at a constant speed. As time goes on, they're not getting faster, they're not getting slower, they're just at a constant pace. Okay, so sorry about that. So this one, they didn't even start at home, but they're also not moving. They're just staying put somewhere. This is a constant speed towards home. Constant speed away from home. So the main thing I want to show you is that these straight lines mean a constant speed. They're not going faster, they're not going slower, they're just at a constant pace. Like if they're walking, it's just a constant pace. Constant, and then they just stop. Okay, they're going kind of slow, and then they speed up. And you know they're speeding up because the curve is getting more steep. Okay, this is pretty steep, so they're going pretty fast, and then all of a sudden they're slowing down. They're staying at the same, pretty much the same distance as time goes on, so they're slowing down. Are they going away or towards home? Okay, if home's here, are they going away or towards home? Well, as time goes on, they're getting further up away from distance. Okay, so they're going away from home. Did they start from home? Mm-mm. Okay, if this was a race to the 2 meter mark, a very short race, okay, between three runners, who wins? So we're looking at the 2 meter mark right here. This is 2 meters. Who got there first? Okay, let's see. Well, if this is time in seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Okay, runner number 1 got there in about a second and a half. Whew, they're lightning fast. Runner number 2 got at the 2 meter mark about 2.5 seconds. Okay, and at the 2 meter mark, runner 3, 5 seconds. So the winner would be the more steep line, runner number 1. Which hiker traveled the farthest in 5 hours? So here we have hours down here. Okay. Well, if this is hour 10, then it's going to be halfway here. So this is hour 5 right here. So this is what we're looking at. Hour 5. And it's asking which hiker traveled the farthest at the 5 hour mark. Okay, well, this traveler only went about, that's kilometers, a little over a kilometer. This one at the 5 hour mark was about a little over 2, about 2.5. And this one, oy, about 4.5 kilometers away in 5 hours. So number 1 got the farthest in those 5 hours. A bicyclist cycles from the origin to a position 4 meters away. Okay, so she starts here and she's traveling at a constant speed 4 meters away. Stays where she is for a little while. Okay, maybe she's sitting at a park bench and saw, I don't know. Well, it's in seconds, so it all happened pretty quick. So she just stayed where she was for a little bit. And then cycles back to her starting position again. Okay, and you know she's going back to where she started because it's going back to the 0 position mark. Okay, so here's a little scenario of that. She left home, remembered she forgot something, stopped, and then went back home. She didn't even get as far as down the street. That would be the scenario here. Okay, so here's some things that you need to make sure that you write down and make sure you have these in your notes. Okay, what distance is, where it goes on the graph, what a curved line means, what a straight diagonal line means, what a straight horizontal line means. Okay, make sure you have complete notes. I have mine, and I will probably be asking for these notes next week. Thank you for watching.